Cool. So we talk about dynamic verification, right? The JS test, like the unit testing, the black box testing. So those are like dynamic verification, like we run the code and we get an output after we run the code. And we compare that output with our expected output. And then we can know if there's anything wrong. Yep, so that is dynamic verification. So the verification during runtime. So we run the code. But is there any way that before we run the code, we can get some information about whether something is wrong? Okay, so this is like static verification. So the static verification that we will focus on today is about tabs. Okay, so here's a recap. Like we talked about JavaScript in the first week, and you have done some practice about using JavaScript. And you may figure out that, well, you feel like JavaScript has no tabs. Like we have the feeling that JavaScript has no tabs. But does JavaScript have tabs? We'll figure that out. Okay, cool. So here's an example. So what this does is, given a string, we repeat that string for repeat times. Okay, and then we console log the repeated string. So let's try that out. So before I run it, what do you think of this piece of code? All good? No good? Looks good to you? Sorry? Sorry,
You can use a different style forward.
Oh, can you use a different style forward? Yeah. But it's not wrong, right? Is there anything wrong with this piece of code?
You're using bar instead of left?
It's all good. Anything else? Yep. Passing the wrong tab. Okay. So cool. So let's run it. Many string root. Where's my many string root? Oh, what about if I change it somehow, like this? Can you figure out if there's something wrong now? What is wrong? Oops, too big. What is wrong? Yes. Okay, so let's run this piece of code. Oops. Clear. By the way, I've already uploaded this new code, the lecture code to the repo for the lecture code. Okay, so I've updated that repo. Node, source folder. So this file is called 3.3 many string root.js. So no output. Well, so yeah, so there are ways that you can capture what is wrong by writing some JS tests, like the expected output is different from what is actually output. But if we do not have that test, there's nothing printed out, and we may, like if we have a large, like big code base, like we cannot figure out what is wrong. So it would be better that we can find earlier, like we had a hello, so a string, like fit into the repeat, which should be like a number, and 5 into a string. So about tabs. So do repeat and a string have a tab? Do they have a tab? Yep. They do, but any tab. Yep. So there are ways that we can figure that out. It's by using, console log tab off. So there's a keyword called tab off. You can know what tab is that. So we can have let's print that out earlier here. Type of repeat. And we can also print out the type of string. Okay, so we can have some like debugging in our code, like to figure out those types. So let's run that again. So they do have a tab. The only thing is that we did not define the tabs. And we can also change the tabs. So for example, we have initiate like string name, and we initially assign it with a string, and then we can always change later and assign another value like a number to it, like integer to it. So it's fun. So this is JavaScript. So here are the tabs in JavaScript. So they do have tabs. You can figure those tabs by using type of. So here's a recap. So we have numbers, we have strings, we also have booleans, we also have object and array. And Java tabs are quite dynamic. So as we mentioned earlier, like we let x and x equals 5. And when you tap off x, you can know that now x is a number. And then we can assign join to x. And now x is a string. So the tab is dynamic and can be changed. And we can also do something like this. So what do you think of what is happening with the type of x during we do this calculation, during this process? Yeah.
If JavaScript will do type conversion for the string, it will try to convert multiple into a number, but it's not a number, so it will be converted to the bottom.
So what do you think x will be?
Not a number.
What is it?
An AN.
Let's try that out. I'm using my code here. So let's console log x and see what will happen. Have you changed your man? Did you change your man? No? My code 20 wall. It's not an AN. So what happens here? So with JavaScript, it's like weird, right? So we'll do from the beginning, from left-hand side to right-hand side. So 16 plus 4 equals 20. And when they want to calculate the sum of 20 and wall, they change the 20 into a string and put two strings together. So this is JavaScript's tab. It's so dynamic. Right. So sometimes it can bring some errors into our code, like we cannot figure that out earlier. Right. So it's not tab safety. It's not safe. Cool. So you can know more about JavaScript data tab here. Like I provided a link here, so you can download that slide and can read more about that. Yeah, question.
What if we use constant x? Would that be good? If let's just say we assign x to a number, then we can't change it this way. We use constant x.
Good question. The best way to figure that out is through a demo. Oops. So this is right. So you want const. You cannot do that. So if you cannot, okay, let's try before I explain. If you see an error message, you can, like with a constant declaration, you cannot change it later.
Also, like x has to be undefined. It can't be changed to a number or string.
Like you need to define it here, and you cannot change that later. So this is const.
No, but in const x be like just undefined. Like you can't change it to a number or string.
No. Yeah. Cool. So this is JavaScript tab. Where's my? Yep, it's here. Cool. So this leads to the like unexpected output. Like we wrote a very nice function, like many strings, but when we use it, sometimes we may forget like how to use it. So the worst mistake a program can make is the one that does not cause an error. There's no error message print out, like we cannot know where something went wrong. So is there a way like we can protect against that? One potential way is to check whether we input the correct tab, like we use the tab of, and if the tab of repeat is not a number, then we console log an error message. And if the tab of string is not a string, and we print out like an error message. So it's like debugging. But we want a more like efficient way. So this is like we introduce tab safety. So preventing mismatches between the actual and expected type of variables is called tab safety. Tab safety. And C is tab safety, right? So when in C, when we initiate a new variable, we need to declare what tab is it, right, in C. But in JavaScript, we do not do that. So it's flexible, it's easy to use, but sometimes it can also can also cause some thing went wrong. So it's not tab safe. So the solution, so there is a solution. So the solution is by introducing TabScript. Okay, so what is TabScript? Is it a new programming language? So we only learned JavaScript for 3 weeks, and now we learn a new programming language. What is it? Don't be overwhelmed and don't be scared. TabScript is something built on top of JavaScript. And the only difference is TabScript has tabs and JavaScript do not have tabs. If that makes sense. So you can always convert your JavaScript file into a TabScript file by adding tabs. So I will show you how. Okay. So here's an example of a TabScript code. Okay, so if it's a JavaScript code, we have like function mySum A, B, and then return A, B, and console logs mySum 1 and 2. But now something additional is here, like number. So it's declaring the tabs of A and B. Right? And the file is also called .ts instead of .js. Yeah, so the differences between TabScript and JavaScript. And all the functions from JavaScript, you can still use that. For example, the array push, the array length, and the others. You can still use those. The only difference is the tab. So JavaScript is a loosely tabbed language. And TabScript allows us to specify the types of data being passed around within the code, and has the ability to report errors when the tabs don't match. So for example, if we have a function called mySum, and the two parameters here, A and B, are numbers, and when we call this mySum, and we have like mySum A and B, there will be an error message. Okay, help us know there's something wrong with the tabs. So how do we run this code? Another dependency that we need to install. Yeah, so it's a dependency. So it's built on top of JavaScript. So TabScript is built on top of JavaScript. And it's a dependency that we need to add to be able to use TabScript. Okay, so let's install that. npm install save that TabScript TS node. And I will explain. Okay, it's installing, great. Yep, so now we can run this code. Here's my code, my code.ts. How do we run that? Have a guess. Like last time when we installed a dependency called jest, before we added the script in package.json file, do you remember how we run jest? Huh? Yeah, node module. Like we find the jest in node module folder, right? So this is the same with TabScript. So it's also a dependency that we install. So this is the line that we run, ts, and this is in my source folder, my node.ts. Yep. So it successfully print out three. So console log the three. Let's have a try like my sum A and 2 and see what happens. Here will be an error message, right? So it cannot have sum of A and 2. So if it's JavaScript, it will print out A2. But now for TypeScript, it's more safe for us, like type safe for us. So there will be an error message and tell us the parameter should be a number instead of a string. Yep, so this is how we run TypeScript code. So we mentioned earlier that like testing if everything works during runtime is good, like we can get some error message, but it would be better like without running the code. Like if is it possible for us to not run the code but check whether there's something wrong with the tabs? Is there a way to do that? So there is a way. Here is it. Oops. I will explain later after I showed a demo. Yep, so if it didn't run the code. There's not, but it figured out, like found one error, right? So this is what is printing out, like an error message. But it didn't run code. So if it ran the code, it will show like a lot more additional like error message here, but it didn't run here. Okay. So it's called TSC. The previous one that we use is called TS node, like run the code and check the tabs. And the later one is called TSE and dash no implicit any. I will explain what is implicit any later, okay, later in this lecture. But now let's just try and use that. Another thing that you may have also noticed that there's a new file created for us. Let me delete this mycode.js. Move to trash. So here's only, oops, where is it? So you can see that we have mycode.ts. Okay, so this is the only mycode file called mycode.ts. However, when I run this TSC, I had a full. Oh, thank you so much. Yeah, so there's a new file generated automatically when we run this TS code. It's called mycode.js. So what is happening when we run TypeScript code? It actually automatically compiled our TS code into JavaScript code and run node.js code. Yeah, so when we run TS code, like TypeScript code, it compiled it into a JavaScript code and run the JavaScript code using Node. So this is what actually happening at the back end. However, you may also have noticed that when we use ts-node instead of tsc, there's no new file generated. So let me show you. Let me delete this JS code and run this file with ts-node instead of tsc. Like tsc checks the tab error without running it, but ts-node run that code and check the tab errors. Okay, so let's run this ts-node. Okay, error message, yes, but there's no new JS code generated for us. So this is a powerful feature of TS node. Like it skips that step, like generate that JavaScript code and run that JavaScript code, but it directly run that TypeScript code. But you can think that the back, what happening at the back is the same. Still compile it into JavaScript and run that JavaScript, but it's faster. Like TS node is faster. If that makes sense? Yeah, question.
Does TS node run based on JS, like in the backend?
Yes. Yeah.
But it doesn't generate the JS file?
No. So it's faster. Yep. Cool. So this is how we run TS code. Okay, so similar with Jest, like we can add in package.json a shorter version, like we do not have like no dash modules slash dot beans and then Jest. So similar with that, we can also add a script in our package.json file. So we can have something, where's my package. So here's my package.json file. So I can add these two lines. Oh, not that one. This one, TSC, and the TS node. And then after you add those two lines, when you run, you can use directly, what is it? How to run it after I added the two lines in the script. How to run the TS code now. npm run. Yeah. And so it needs to be npm run TS node. Right? Yeah. So like when we run test, we have npm run test. Yeah. Yeah. So this is similar. So it's npm run TS node or npm run TSC. Yep. Yep. Makes sense. So it's similar when we run the Jest test. Okay. Yeah, the error message. Yep. So, oops. So this is how we run TS code. Yep, and in your labs, all this has already been set up for you, those scripts, like how to run. So you only need to use directly npm run TSC or npm TS node and the code that you want to run for your labs. And also project iteration too. So we have already set those up for you. How to TypeScript? We'll practice TypeScript in the labs and also project iteration too. There are a couple of ways that you can practice that. The first one, the more straightforward one, is try to convert your JavaScript files into TypeScripts by adding tabs. Yeah, so this is one practice you can do by yourself, like before iteration 2. But during iteration 2, we will also give you some tasks to practice, like converting some of your JavaScript files into TypeScript files. Okay, like one interesting or like was a very good question that I was asked during the middle break is some of you convert your JavaScript file into a TypeScript and then run it directly. And for example, my code, this one, and then change it to .ts directly and run it in a TypeScript way, like TSC or TS node, and there was no error message. Why? You know why? Because in this file, we didn't declare what type A or B should be. And then it would just run in the JavaScript style. So no error message was there. Okay, so if you want to run the TypeScript more properly, we need to add types to it, like the types of A or the types of B. Sorry. Okay, so we can just add, like for example, number to A, number to B, right? So we have seen that example, and sometimes it runs properly. Like we just had A and B, but did not declare what type A and B is, and we TS node run it. Everything works well. The reason is that there are two groups of types in TypeScript. One is called explicit type, like we declare what name is a string. And the other one is called implicit types. So TypeScript can guess the type for us. So if we do not declare what type is it, TypeScript will guess that for us. So for example here, constant name is team. Okay, so we did not have like after name we had dot string and then equals team, but it will still works well, because TypeScript will guess the type for us. Sometimes it's quite easy for us to guess, for TypeScript to guess. For example, this one, like TypeScript will know directly like name is a string, right? However, like in the function, like the parameters, if you do not declare the type of the parameters, TypeScript cannot guess what is it. So if you have like function hello name directly and then the scripts in your function, like there's no way for TypeScript to know the type of name. So it's mandatory for us to declare the types for all the function parameters. Sorry. Okay, so let's see some examples. So the most basic three types in TypeScript are string, number, and Boolean. So string, like obviously those with quotes. Number, just 1, 2, 3. Booleans are, what is Boolean? True or false, yes. And functions typically require all parameters to be explicitly tagged. Like as we mentioned, like TypeScript cannot guess the type of name, like function parameters. So we need to declare the type of function parameters. It is required to be explicitly tagged. Okay, so this is something new, unions. So this concept is, sorry, is new for TypeScript. Okay, so example unions. So this is our example. So you can see normally we have only one type for one parameter. We had A is a number or a string is a string, like when we declare the parameters for a function. But here we have Boolean or number. So yes. So unions means that ready can be either of Boolean type or number type. Right. So if you have ready as a number or as a Boolean, there will no error message printed out. So either way, it's fine. So let's try it. This is my example unions. Yep, no error message. We can also check if it's all good with the tag without running it by using TSC. Yep, all good. So either Boolean or number is fine. Okay, so this is union. So this is what we mean by union. And next one is array, like how we use tabs in array. Do you remember how we use tabs in JavaScript? Like, can we have an array in JavaScript with A, 1, 2, B, C? We can do that, right? So in TypeScript, we can also do that. But we need to declare it beforehand. Like, what are the allowed tabs in this array? Okay, so we need to declare that. So in this array, so list array is the variable, okay, and it's of array tab. And in this array, we can have strings or numbers. So we initiate this list array with 1 and 2, and if we push an A to it, everything still works well. So let's try it. Example lists. So this is my TS file. Okay. So let's run it. It's called lists. Yep, TSC all good, works all good. Now we can also try TS node to actually run it. So we've got 1, 2, and A. What about we try to push something else? What about we try to push a true to it? What will happen? 1 to 2? Yeah. Okay. 1 to 2? It's not allowed? Yep. Okay, so let's try and see which one is correct. Error message. Okay, so argument of type Boolean is not assignable to a parameter of type string or number. So true cannot be pushed. Yep. All good? So we can have A here, all good. We can also have like make true a string, and then you will be able to push that to that array. Okay, so let us try that. Now you got 1, 2, true. Yep. Yeah, I'm not sleepy, Eric. Okay, cool. So this is how we defined a lot of tabs in an array. So, any questions so far? All good? Alias, what is that? Have a guess. Yeah, by definition, tab scripts allows tabs to be defined separately from the variables that use them. What is it? So we can define a tab of our own. So the most commonly used tab in tab script are string, number, and boolean. But we can also define our own tab. For example, list item is a tab in addition to string, number, and the others. And in this list item tab, it can either be string or number. Yeah, question. What tab? If we have an object, what tab that be? Okay, that's a good question, and we'll see that very soon in the future examples. Cool. So this is how we define a new tab called list item. And now when we declare a parameter, we can use list item, and it will be equal to string or number. It will be the same. Cool. Yep. Okay, so optional parameters for functions. Have you ever tried optional parameters in JavaScript? No? Okay, so let's try it now. What example should we use? My code. Okay, so let's use this example in my code, but let's use the JavaScript version. So we defined a function called mySum, and we have two parameters called a and b. And when we call mySum, what if I have one more parameters here, like string, in JavaScript? What will happen? Let's try.
Just similar as a plus 2, but instead a plus changing 2 into 5.
Maybe. Yeah. Okay. Error message, perhaps.
If you can add 2, I think you can add 3.
If we can add 2, then we can add 3, so it'll be equal to a plus 5.
Yeah.
Any other potentials?
Maybe
Ignore the third one. Yeah. Agree. Any other thoughts? Let's try. Okay, let's try it. So, so this is a JS code. So just node mycode.js, mycode.js, A2. Yeah, it ignored the three, like the third one. So this is what happens in JavaScript with the function parameters. But what about in TypeScript? What will happen in TypeScript? So now we have 1, 2, and we add one more like 3. Guess what will happen? No, it's an error. Surely. Okay, let's try. This is called 3.3 mycode.ts. Yeah, an error message. Yes, you are correct. Yes. So, what if sometimes we want a third parameter inputs, but sometimes we do not need that. What if we want additional parameters as optional in TypeScript? Okay, so this is how we use that. So we can have like the first two parameters are mandatory, are required, and we can have a third one which is optional, and by adding a question mark after the parameter's name. So for example, and here is the third parameter which we want it to be optional, and by adding a question mark, it becomes valid optional parameter. Yep. Okay, so let's try it. So here's my code. Example optionals. Okay, it's here. So let's ignore those for now. Okay, so this is our code. And we have the third parameter and of a number type is optional. Okay, what happens in this function is that we want to start from the numbers item from the string. So for example, we have a string called sunny day, and we want to print out the index from index 0 to index 3 for this first console log. Okay, so let's try this first one first. Before I run it, what do you think will be print out? Example option noise ts. It will be from SUNN, right? Index 0 of sunny day is S. Index 3 of sunny day is the second N. Yep. So, oops. 0, 1, 2, 3. Oh, yes, you are right. Because I is less than modified and, meaning that it stop at the second, right, the index 2. All good? Yep. But the third parameter n is optional. Sometimes we do not have, we want to start from the number, like index number, to the end of this string. So we do not indicate where to end. So we ignore the end, and it will be to the end. So the third parameter is optional here. And there are two different ways. Yeah, question.
Is it good practice to specify the type of the return value?
Yes. Yes, we can specify the type of the returned value by doing this. Yeah, that's right. It's a good practice. Cool. So the first way of having an optional parameter is by using n with a like the parameter name with a question mark. The other way is by using number or undefined, like this. Oops. So they are the same. So number or undefined is the same. So if we do not have an and parameter input into that, for example, this second example, the type of and will be undefined by default. So we can also have something here within like this. So you can check the type of and. And if we do not have a third parameter, it will be and is undefined. Yep, so they are the same. All good so far? Yep, you can practice by changing your existing JavaScript file into TypeScript file. Okay, and then you can practice using TypeScripts. Okay, objects. Okay, objects have in TypeScript. So in the previous example, we show like we can have aliases for the tabs. For example, we can define our own tab, right? So we can define our own tab as either string or number. But here for an object, we can also define a tab called student. And in this tab, we have a few, like name is of a string, group is of a string, and similarly, we can also have optional properties in this object tab. Question? Yeah, yes, you can use interface. Yep, cool. Okay, so let's have a look at this example. Example, objects. Okay, so now when we declare the type of user, we can declare it as a student. And in this student, we have a couple of properties like name, group, mark, class. And is Samir here? Samir got a 100 mark. Okay, so this is how we use object tabs. Okay, and this, the mark and the class is optional, but when we initiate the user of a student tab, the name and the group are mandatory. They are required to be declared here. Cool. Another one is called literal tags. It looks pretty similar to like when we declare the type of when we define our own tabs. But here is like visibility here. So it's different. Like when we declare our own tab, like for example visibility, it was either string or number of otherwise like strings or boolean or string, right? But here the tab is called private or public. So it's our own defined value. So visibility here like can only be either public or private. Cannot be changed to other strings. Yep, all good? So this is, okay, so the last one we'll talk about today about the types of TypeScript is called any. Oh, so this is a little bit tricky one. It's a special type of TypeScript. And you can use it whenever you do not know what type that variable will be. Like when you write a stub, like empty function, like you want just put it there for now and you make change to that. And there are a lot of uncertainties about that function or that variable. You can use any for now. And by default, like when you do not put in a tab for the variables or the parameters, it will by default of any if TypeScript cannot infer the type of it. Like for example, if you have a const name, Jonathan, they know the name is of a string type. But sometimes TypeScript cannot infer the type of the variables or the parameters. And if you do not declare that clearly, TypeScript will use any by default. Normally, we want to avoid this. So we want to have clearly defined tags in TypeScript. So this is why we had the compiler flag, no implicit any. Like when we run TS node, we had no implicit any. Or the TSC, no implicit any. It's because we want it to flag any implicit any as an error, because we do not want that to happen. There's a risk of type safety, like being unsafe. Okay. There are a lot of different information or like types or like arrays, objects in the TypeScript website, and we provided a link for you. You do not need to know everything. Again, like you do not need to know everything. You only need to know where to find this information. Okay. Yep, another question I was asked was, like now we can search online for all the functions, all the method, all the, like everything for the project, for the lab. So what about the exam? Like, can we have everything? The answer is that we do not have an exam. Yeah, we do not have an exam. So we only had projects, so the major project and the individual project. And the individual projects works very similar to the major project. The only difference is that it's individual based and it's much, much smaller. Question?
Is there a way to have something like some way of giving documentation locally? Because I don't always have the internet, so I can't just like look up things on the spot.
What do you mean by keep everything locally? Like,
so if I want a function that does whatever, is there like some sort of way I can access that function without using the internet?
Maybe there's a way of printing out that documentation of TypeScript, like the online website. There's a documentation of TypeScript. Perhaps there's a way of downloading it. I'm not too sure, but you can try. Yep. Cool, and here's a list of documentation, all the steps, and how you can migrate from JavaScript to TypeScript. However, you do not need to know all of this. We have already set up everything for you in the labs and the project. You can use npm install, and all the dependencies will be installed. Okay, so we have already included everything in the package.json file. So to start working on the labs or the project iteration 2, you only need to npm install. Okay. Okay, so another question is, like we used just test with continuous integration, like CI, the pipeline. Is there any way like we can also check the tabs in the pipeline so that it automatically test the tabs for us, like what we did with just test? And the answer is yes. And very, very similar to what we did with just test. We only need to add another script which is called npm run tsc. Like without running the code, like whenever we commit a new change, it will check the tabs for us. Okay, so you can also separate the just test with the TypeScript tab checked in different stages. But you can also put them together, so it's up to you. Right, so this is one way of adding the tab check in the continuous integration. Okay, no stress, no stress, no stress. So this is the only lecture that we do today, and you won't be able to use it, must have it to next week lab and iteration 2, but you can start practicing it using the labs. And also the environment, like you also do not need to worry about the environment setting. In the lecture code, that I share with you, I already set up the environment, and you can use them directly. For the labs and the project, the environment is also set up for you, that you can use it directly.